So I want to go through a couple of these free response questions just to give us some more practice with doing these kind of tests. We have two different tests. One is the one that we were talking about before we left, and one is our
goodness of fit.
Well, we have goodness of fit, but we also have have this new chi-square test of association and independence.
Gosh.
So first off, let's talk about goodness of fit then. How do we know it's not goodness of fit here?
There's two variables.
Yes, there's two variables. So remember, goodness of fit is just for one variable. And it's talking about the distribution of that one variable. Now, I talked about the difference in my in the notes video between these. So we have homogeneity and association and independence. Okay, so first off, there's a clue in the problem that we're doing a chi-square test of association and independence. But the other clue that we're using chi-square test of association and independence is that association and independence is just based on taking one sample, whereas our homogeneity tests were the tests about either two different samples, so taking separate samples and comparing them, or taking a sample and splitting it into groups, like doing an experiment where you have like 3 different treatments. So based on the fact that we're just taking a random sample of 200 and then putting them into, and then asking them the questions, then that's going to be association and independence. So a lot of times it's going to be clear which one we're going to use. So sufficient evidence to indicate that the response is dependent on gender. So the fact that we're using the word dependent probably gives you a clue that we're talking about independence. But another way you can tell is by, are we just looking at one sample, or are we splitting the sample up in some way? Do we have 2 separate samples, or do we have a sample that we are dividing into 2 different treatments, like an experiment? Here we're not. We're just asking male or female, and what category are you in for the question. Okay, does that make some sense? Any questions on that?
Yes, makes sense.
Makes sense, okay.
Sense. Yeah.
All right, so for our null and alternative here, we get into the space that I want. Okay, there we go. Null hypothesis. Well, null hypothesis, we can state it out in 2 different ways. I'm going to state it out with association because I think that's the easier way to phrase it. So with association, the null hypothesis would be that there is no association between a person's response. Well, that's annoying. Okay, how do I want to do this? I did not anticipate this problem. Let's do it this way for now. And I'll zoom out if I need.
Oh no.
Oh gosh.
Muting because there's a lot of feedback. Okay. Between a person's response to the question and their gender. Okay. And then the alternative alternative hypothesis, close enough. Alternative hypothesis is that there is an association between a person's response to the question I think you ought to correct their gender. And then we would write that we are using alpha level of 0.05. Step 2, everyone's favorite part.
Yes.
Yes.
Random sample of 200 students from a large college.
Again, the main thing to keep an eye out for in the random condition is, do we have a random sample that we're taking, or is the random that we are randomly assigning people to the groups? Here, we're taking a random sample of 200 students. There we go. Oh, not normal, not normal.
Large sample size.
Large sample size. Edit, what are my dimensions?
2 by
2 by 5.
2 by 5.
2 by 5. So we have 2 rows, 5 columns. And one of my suggestions when you do this, just to make sure that everything is entered properly and makes sense, is to check at least one of these by hand. I wouldn't make you work out all 10 of these by hand, but my hope is that you should check one of these by hand, just to make sure that your calculator is doing it properly and that you didn't type something in wrong or anything like that. So, for example, for my first cell, my top left, the one that's highlighted here, remember that that's row total times column total over grand total. So I have 30, 50, 80, 90. So I should get 90 times 30. That's row total times the column total. And then divide by our grand total, which is 200. Okay? So 13.5, if it's doing it correctly, should be the expected count. Stat tests. Remember, these chi-square tests are in the same menu. Observed, expected, calculate it. Okay, and we'll come back to that in just a second. But the reason we're interested in it is because we want our expected counts. Edit. There's our matrix. Hey, 13.5. Did it right. No. This way, so that I can write down expected counts are, and then I would just copy the matrix. And so I'm just writing out and copying down my matrix of my expected counts. Okay, so all are greater than or equal to 5. What? Oh, that's what happened. I hit a button over here. All are greater than or equal to 5. So that's our large sample size. independent, there are at least 2,000. That's 10 times the sample size. In the population. Okay, so the main thing to emphasize there is you can write down the matrix and get your to get your expected counts. Okay, and in that way you can refer back to it when we get to step 3 and writing down the formula. Isaiah, did you have a question?
Yeah. Do we have to write down the entire matrix every time we list the expected counts?
If you're listing the expected counts, I believe that they will accept, another way they'll accept it is sometimes they'll take you writing down the smallest expected count, especially if the matrix is really big. Like this is tending towards a larger matrix. So for example, on this one, to say that the smallest expected count is 13.5, and that's at least 5. That shows that you've checked them all, you've written down the smallest one, and it's bigger than 5.
Okay.
So like I said, our typical way is going to be write down the first 2, put a ... and then write down the last one. So which equals, and then I'm going to have to go back to my chi-square test. Degrees of freedom. So remember, it's rows minus 1 times columns minus 1. So that is going to be 2 minus 1 times 5 minus 1. And that is 1 times 4 is 4. Again, that's more than you would likely need to show. I'm just showing it out so that you have that. I would say this much would probably be enough. Let's get our chi-square value. So now we can write down our values. So we have 8.923. Degrees of freedom is 4. So probability that chi-square is greater than, always greater than, the 8.923 equals 0.06306. P-value usually goes to 4 decimal places. Since our p-value is less, no, it's greater. It's greater. What am I doing? Then I'm rusty because we've been away. Greater than our alpha level of 0.05. We failed to reject the null hypothesis. I'm typing it out because it's quicker than doing the subscript. By the way, if you have a question as I go along, you can post something in the text chat as well. Or you can do what Isaiah did and do a raising of the hand. And I should be able to see that as well. There's not enough evidence. Of an association between response to the question and gender. Ignore that the start of every line is capitalized. Okay, so as always, compare it to your alpha level, say whether you reject or fail to reject, and then what do you conclude about the alternative? All right. Let me minimize the calculator so you can see that. Okay. Anything on that problem? Or are we set to go on that one?
I think we're good.
That's your typical four-step process there.
You know what's really frustrating about that one, though?
What?
When you put in your matrices in step 2, you can literally just be done with the problem. It gives you a p-value.
Listen, what I always did when I was a student doing these.
Can you mute people again when you're talking?
Yeah.
Yeah.
No, that unmutes everybody. There we go. When I was a student doing these free responses, what I would always do is I would do the calculator stuff last. So I'd leave the the expected counts part blank. I would still plug in the formula part, but I would wait to put in the chi-square value and the p-value. I would basically write out most of step 4, and then so I would have like pretty much everything written out so that I didn't have to take a break from writing to go to the calculator, and then I'd fill in the blanks that the calculator needs to fill in. That just helped me be faster with writing it because I knew so well exactly what I needed to write word for word. So if time is a factor for you, that might help make things easier as far as getting through things quickly. As long as you're good with the phrasing and the writing. So anything else on that one?
We're good.
All right. So what I'm going to do next is for this next one, this is the next one. So let me explain this. As I think I've said to you before, the AP grading splits most of these parts of questions, grades it one of 3 ways. So they said either they give you either essentially correct, which is full credit, partially correct, or incorrect. And partially correct is usually that either there's parts of your explanation that are missing, there is you made a little arithmetic mistake along the way, you didn't say something that you should have, or you got to the right idea but aren't quite phrasing it in the right way. Those things are partially correct. And an incorrect is like you didn't show any work, or you're just very far off track. So I'll tell you that with the work shown, 0.552 would be partially correct. You get partial credit on this for 0.552. And
Yes, that's absolutely 0.552 would be, remember that the probability, all the way back to probability. Okay, that's a general formula for an OR probability. Probability of A or B is probability of A plus probability of B minus probability of both. So yes, you don't want to, the people who are in both categories that get their source from the internet and other graduates are being double counted if you just add them together. So you want to take, these are all out of 2,500. So the process that you would go through, where are my numbers? Are you would do 693 plus the 687, and then minus the people that are in both, which is 245. And that equals 1135, and that's out of everybody. Okay, so again, if you said the 0.552, you would still get partial credit. But if you just put the decimal with no work, it's marked as incorrect. No credit for just the answer with no work. In some way, you have to show how you're getting that answer. This is the probability. This is the probability of if an adult is a college graduate. So given college, what is the probability of internet? Okay, probability of internet given college. Okay, and so out of everyone that was a college graduate, 693. How many of them got their news primarily from the internet? That's 245. Okay, and that is indeed their answer key over here, rounded it to 0.354. Okay, let me open up the channels here. What did we think about this one?
What one? Part C?
Yep.
I said it wasn't independent.
I also said it was not independent.
Yeah. No independence.
Paige, what did you say?
I couldn't remember how to do this one, so I did not answer it.
Okay.
Well, isn't it no? Because if it's like 1, it changes the probability.
Yeah, I knew something
How?
else like if they're equal, then, or if they're the same thing, then they're not independent.
If they're the
Paige
same
is
thing,
the
it's
CEO.
So like, I don't know. But like a coin flip is independent because getting heads on one flip doesn't affect the result of the other, but this is not independent because if you are a college graduate, that changes the probability that you use the internet. And if you like choose the internet or whatever, that changes like the probability that you're a college graduate, right?
Can you show that through numbers?
Most likely, yes.
Because that's what you need to do to get full credit. You need to show that through calculations.
Does this look familiar at all?
Yes.
Oh yeah.
So let me mute so I can explain real quick. So this formula is a way of, through getting the probabilities and proportions, showing which things are, whether things are independent through calculations. Okay, and so what this is saying is basically the same definition of independent that you have told me kind of informally, which is that knowing that one thing has happened doesn't change the outcome of the other. Okay, so in other words, probability of B given A, that is, I know that A happened, what's the chance that B has happened? And what this equality says is that this doesn't change. So if I know A has happened, that doesn't change the chance that B happened, just because I know that A has happened. So for the coin flip example, just because I know the first flip is heads, okay, that would be event A, knowing that the first flip is heads doesn't change my chance of the second flip happening. Okay, so in this case, we would have, if we wanted these things to be independent, then here's what should hold. The probability of, well, let's use the probability that we just found, which is internet given college equals probability of internet. So these are the two probabilities we want to compare. Well, this probability we just found, it was 245 out of 693. We just found that in part B. So we already did that. Over here, probability that they use the internet is 687 out of 2,500. So this was 0.354. This is 0.275. Okay? Not equal. So this is what you would show to show that these things are independent. And you have to have that calculation. So just to go through that one more time, the idea is, if you're trying to figure out whether these two things are independent, is I tell you, I ask you, what are your chances that someone gets their primary source of news from the internet? Okay? You think about that question and you get the probability and the chance that they get their news from the internet. Okay? Then I tell you, okay, now I'll also tell you that this person graduated from college. Now, what is the chance that they get their news primarily from the internet? Okay? And if that changes your chances, then the things are not independent, because knowing that they're a college graduate changes your probability. In this case, it makes it more likely that they get their news primarily from the internet. So that's how you know these two things are not independent. And it's a calculation way of saying that one of these things has an effect on the other. That knowing they graduated from college changes the probability that they get their news from the internet. Degrees of freedom?
10.
8. Oh, wait, am I stupid?
It's 8, right?
Oh, shoot, it is 8.
I said 8.
Yeah, I can't subtract or add. So
You're the one that always gives me a hard time about writing out the degrees of freedom every time.
Wow.
Yes, yes. That is 4 times 2 is 8. Number of rows
CEO
minus 1.
multiplication.
Number of columns minus 1. Okay. So any questions on those parts?
No.
So from what I saw,
Think we're
most
good?
of you would be getting like 2 or 3 points out of 4 on that right now. You'd be getting part B right. You'd be getting part D right. Some of you would get part A right. That's what I'm gathering from what you guys have said.
Mhm.
All right. Sounds good.